Okay, so graphing tangent and then cotangent. I'm going to start around the circle, and I'm just going to write the tangent values. I'm going to go kind of quick. At 30 degrees, that's one with all the threes, radical 3 over 3. Then we've got 1. Then we've got radical 3. And then it's undefined. All right, and then in this quadrant, it becomes negative. So negative radical 3, negative 1, negative square root of 3 over 3, and then 0. And then in this quadrant, it becomes positive square root 3 over 3, positive 1, positive square root 3, and then undefined. And then we'll finish it out negative square root 3, negative 1, negative square root 3 over 3. And then I probably should have started at 0, but 0. But when I take those and I write them in a table, I'm not putting the decimal, I'm just writing the values. Hey, what's going to happen at undefined? Not everybody at once. I can't understand you because you're all talking at once. What's going to happen at undefined? Lydia, what's going to happen? There's going to be an asymptote. So you can already see that tangent's different than the sine or cosine, because we're already starting with an asymptote, where we didn't get asymptotes in sine and cosine until we reciprocated them. I'm just copying down these values going around the circle. So if you can't keep up, it's not the end of the world if you don't get this all copied down. Okay, I do have to zoom out just a teeny tiny bit. You're probably not going to be able to see the values perfectly from where you're sitting. But what I need for you to notice is that if I start at 0 and I go to pi, 0, radical 3 over 3, 1, square root 3, undefined, negative square root 3, negative 1, negative square root 3 over 3. Or if I start at pi and I go all the way down to 2 pi, 0, square root of 3 over 3, 1, square root of 3, undefined, negative square root of 3, negative 1, negative square root of 3 over 3, 0. The values repeat in order. Do you see that? All the values repeat in order. Tangent does not have a cycle of 2 pi. What is the length of tangent's cycle before it starts repeating over again? Just pi. So tangent, we can already tell, is different than sine and cosine. Tangent has a period of pi. We can also see that tangent has some asymptotes in there. All right, so we're already seeing that some of the stuff is different. I don't really need to write the cotangent. The cotangent is just flipping each of these values. So if I flip 0, I get undefined. I'm not going to write it all. If I flip radical 3 over 3, I get square root of 3. If I flip 1, I get 1. If I flip square root 3, I get square root of 3 over 3. If I flip undefined, I get 0. Then I get negative square root of 3 over 3. I get negative 1. And then I get negative square root 3. And then I get undefined again. Then it repeats. So that's how cotangent looks. Now, when we did sine and cosine, we purposely chose values that were easy to graph. So I'm going to look at tangent. I'm going to do the same thing. I'm going to purposely choose values that are easy to graph. I'm going to choose values like 0, which is easy to graph. I'm going to choose pi over 2. And I'm going to choose pi over 4, because those are easy to graph. I'm going to choose a couple others, but you don't actually see them in my table. And you'll see why I chose those in a moment. But I'm going to choose 2 others that aren't in my table. But we're looking for things that we can graph easily, like the zeros, the ones, the undefines. I'm going to highlight on this picture over here the values of tangent that I'm actually going to choose. I'm going to choose these values of tangent, but I want them in an interval that I can write easily. So the values of tangent that I'm going to choose for my key points in my table when I go to put it in my table, I'm going to write it. I'm going to write it right now for you as an interval, and I cannot write one interval that says 0 to pi over 2 and then 3 pi over 2 to 0 or to 2 pi, because that's like not one interval. So to write it as one interval, I'm going to write it as negative pi over 2 to positive pi over 2. That's where I'm going to graph my original tangent first cycle. So I'm basically taking the undefines as like the outsides, my asymptotes. I'm going to have the 0 in the middle, and I'm going to take those ones, the 1 and the negative 1, from the answers. Okay, but I'm doing it starting at negative pi over 2 rather than starting at 3 pi over 2. And I'm going to negative pi over 4 instead of 7 pi over 4. So that's like the only difference. So that's where I'm going to get the values for tangent. So the first thing that you need to know is those values of tangent. They're going to go from negative pi over 2 to positive pi over 2. If you know that those are the ends, you can find the very middle value is going to be 0, because that's right in the middle. And then right in the middle of 0 and pi over 2 is pi over 4. And right in the middle of 0 and negative pi over 2 is negative pi over 4. And we're talking about tangent. These are the values that I'm using for tangent. The top and the bottoms are the undefines, because those are, what we're doing is y over x, and the ordered pair is 0, 1, or 0, negative 1. So we're doing y over x, which is undefined. This one is 0. In the first quadrant, at that 45 degrees, tangent of 45, tangent of pi over 4 is 1. In the fourth quadrant, negative 1. So my values are going to be undefined, negative 1, 0, positive 1, undefined. So I'm going to start in my table here, and I'm going to graph my asymptotes. Let's see, my first asymptote is at negative pi over 2, x equals negative pi over 2, asymptote. And then my next asymptote is at pi over 2. These, oops, I did not graph that at the right place. I don't know what happened there. Pi over 2, there we go. These are periodic, so they will cycle over and over and over again. So my next asymptotes are going to be 4 blocks apart, just like these asymptotes were. They're all going to be evenly spaced. Let's write the formula for the asymptotes. X equals, what's my first positive asymptote? My first positive asymptote. Look in your table, look on the picture. What's the first positive asymptote Caitlin? Pi over 2. So I'm going to say x equals pi over 2. Now we have to add on how much each time before we get to another asymptote. Sarah Nold, how far apart are these asymptotes? They are pi, so I'm going to say k pi. And then remember, k is an element in the set of integers. K is an integer. So I have my asymptotes. We will have a point at negative pi over 4, negative 1. We'll have a point at 0, 0. We'll have a point at pi over 4, 1. Now, this is not a straight line because remember there's other points in there which I didn't graph. I didn't graph all of them. I could. We could go find out the decimal for square root of 3 and square root of 3 over 3. We're not going to do that. I'm just going to tell you that this one has to be concave up, and this one on this side is concave down. They change their concavity right in the middle. It kind of resembles a cubic graph, but it is not a cubic graph because this one approaches an asymptote, and cubic graphs don't have asymptotes. But right in the middle where the concavity changes, that's where it kind of looks like a cubic graph. So that's one full cycle of tangent. And then I just have to repeat that cycle. People have trouble drawing the correct concavity. So one thing that I will do is walk around and see if your graphs are looking right. Not this second, but I will come around and check that out. So this is just tangent. Our period we talked about on the front page, one full cycle is pi. That's the parent function. From there, it'll just change. The domain. The domain, the same way we did the domain with the asymptotes with secant and cosecant, domain is going to be similar. You cannot write it in interval notation, so we're going to write it in set notation. The domain is everything except it cannot equal the asymptotes. So once I know my asymptotes, then I say my domain is not equal to those asymptotes. And then the range. How far down do we go and how far up do we go? Nick, what are you saying? Infinity, is that what you're saying? Yeah. So if we can write that in interval notation, that will be from negative infinity to positive infinity. And that's tangent. So cotangent is just reciprocating all those values. So remember when I had secant and cosecant, I'm going to draw what I was doing with my hands. Remember when I had cosine and sine? Let's see. If we had sine, oops. Remember sine? Sine looked like that. Sine looked like that. And then when we had its reciprocal, I took this maximum piece and I flipped it up. And then I took this minimum piece and I flipped it down. That's kind of what's happening with tangent, kind of. What's going to happen at the zeros for tangent when it becomes cotangent? What's going to happen at the zeros? They're going to become undefined. What's going to happen at the undefines? What's going to happen at the undefines? Yell it out. They're going to become 0. And then when I reciprocate 1, still 1. When I reciprocate negative 1, still negative 1. We are choosing to use a different range of, or I should say domain, of x values. I'm going to go back to this picture right here. I'm going to use, for cotangent, I'm going to use, what color? Bright green. I'm going to use, now I only wrote tangent around there. But for cotangent, just to show you, I'm going to use starting at 0 and going to pi for cotangent. I'm going to use starting at 0, going to pi for cotangent, because when I write the actual cotangent values in here, it will be starting at undefined, ending at undefined. We will have a 1, we will have a 0, and then we will have a -1. So it's kind of the same values, just they're in different places in the two graphs. So can you see how I did the pink first and fourth quadrants? The green is first and second quadrants. So the values of cotangent theta, I'm going to be using 0 to pi in my table, 0 to pi. So 0 to pi, right in the middle is pi over 2. In between those is pi over 4, and then 3 pi over 4. Cotangent and tangent both start with the undefines. Both start and end with undefines. 0 will be the middle. So if I'm using this little picture here to figure out what comes next, if I'm going around this, the next thing I get is a +1. And then I get a -1. I'm drawing these little pictures of the unit circle because you guys are going to have to know these values. They will not be provided to you. You have to know them. So I will have an asymptote at 0 and at pi. And then from there, I follow the pattern to find more asymptotes. I'm going to write the equation for my asymptotes. X equals, what's the first non-negative asymptote? Chris. What? There's 1 before that, that's not negative. 0. So I'm not going to write the 0 because it is 0. I'm not going to write the 0. Does everybody understand I'm not writing the 0? Maybe I'll just write it off to the side. 0 plus, how far apart are they? Pi, so we'll do k pi. Now I'm going to simplify that. K pi. And k has to be an element of the integers. So there's my asymptotes. All right, and then we graph it. Let's see, we've got pi over 4 is 1. What did I do wrong? I did something wrong. Oh, yeah, that's what it was. I'm used to the other graphs. Thank you, Chris. Pi over 2 is 0, and then 3 pi over 4 is -1. This does have the same kind of concavity like tangent did, but it's the other direction. Now these are parent functions, and once we start throwing transformations in there, it really gets confusing. And that's why if you can remember the key points, then you can just make the tables. Because like I can look at these and try to remember that tangent always goes up and cotangent always goes down, but once you have reflections in there, that gets confusing. The period, so 1 full cycle is going to be pi. We put that on the first page already. The domain is not the asymptote, so x does not equal k pi, where k is an element in the integers. And the range is going to be everything, negative infinity to positive infinity. And then I just have two examples because it's all transformations from here. So this very first example, we're doing tangent. So I have to remember that tangent is going to be these points. Tangent is going to go from negative pi over 2 to positive pi over 2. So there's something you have to remember. And then from there, if you don't remember anything else, you can get everything else, because I can say, what's exactly in between these? 0. What's exactly in between these? Pi over 4. Negative pi over 4. I have people that put them in the wrong order and then get really confused by graphing it because they didn't practice enough. And you guys, we should know that negative pi over 2 is more negative than negative pi over 4, even though the 2 is smaller than the 4, it's the denominator. That's where people get confused. And then my values will always start with undefined and end with undefined for tangent. It will have 0 in the middle. And then I need to know tangent at negative pi over 4 is in the 4th quadrant. So that's the negative one. Then at positive pi over 4, that's the 1st quadrant, so positive 1. I'm going to graph my asymptotes. Oh, wait, no, I'm not going to. I'm going to do all my transformations now. All right, we've got a 2. Multiply your y values by 2. What happens when I multiply undefined by 2? Nothing. It's still undefined. In fact, the whole y side where we've got undefined will not change. It will stay undefined the whole time on the y side. Not on the x side, on the y side. Okay, we multiply, we get negative 2, we get 0, we get positive 2. My next step is adding a 3. If I add a 3 to undefined, it's still undefined. 1, 3, 5. So that's my x, that's my vertical, my y side. On the x side, what am I going to multiply by? What am I going to multiply by? Somebody yell it out. Just one person, not everybody at once. Yell it out. 2. So we're going to multiply by 2, and I get, this times 2 cancels out the 2, negative pi. I get, if I multiply by 2, I get negative pi over 2. I get 0, pi over 2, and then pi. Now, what am I going to do in the final column? Caleb. Where did you get pi over 4? Because I do not see a pi over 4 in my equation. Okay, so I need to factor still, is what he's saying. He's saying, you still have to factor. So we have 2 tangent. I'm going to factor out that 1/2 x minus. Now, if you're not sure what that answer is, then you say, well, pi over 8 divided by 1/2 is the same thing as pi over 8 multiplied by 2, which is pi over 4. So I have to factor that out, and I get, I think this is what he said. You said add pi over 4. Yeah? Yeah, add pi over 4. All right, so I'm going to add those pi over 4s real fast. I get negative 3 pi over 4. This is negative pi over 4, pi over 4. And I'm counting by pi over 4s, so you could figure them out, or you could actually add them and find common denominator. 3 pi over 4, and then 5 pi over 4. So my first asymptote will be at negative 3 pi over 4. My last asymptote, not my last, but my next asymptote will be at 5 pi over 4. So here's 1 pi over 4, 3 pi over 4, 5 pi over 4. At negative pi over 4, it is 1. At pi over 4, we've got 3. And at 3 pi, oops, that's not pi over 4. At 3 pi over 4, I've got 5. They should all be evenly spaced, the points and the asymptotes. They should all be evenly spaced. Okay, now I'm going to repeat that process. So I'm looking at how many blocks, how many units the asymptotes are apart. 1, 2, 3, 4. So 1, 2, 3. Here's the next one out there. 1, 2, 3, 4. So I go to fill out my asymptotes. Where is my first positive asymptote? First positive asymptote. Sarah Penny, where's my first positive asymptote? Could you say a little louder? Pi over 4? Is that what you said? Well, at pi over 4, I have a value of 3. I need to know where they're undefined. At 5 pi over 4. That's my first positive. Then we have to figure out how far apart they are. Normally they're pi apart. There was a horizontal stretch on this. How far apart are they? What is the amount of 4 blocks on this graph? How far apart are they? John, how far apart are these lines? 2 pi. So I write 2k pi. And then I write where k is an element of the integers. I have my asymptotes. Just going to copy my pattern. If you can't see all of my asymptote right now, if like you're still writing that down, I will go back to it in a second. Period for tangent is normally pi. We had a horizontal stretch of 2, so this period is 2 pi. We did have a vertical shift up 3. A phase shift is the horizontal translation, so we went right pi over 4. Domain is almost the same as the asymptotes. You're just saying that it cannot equal those asymptotes. And then the range is all real numbers, so negative infinity to positive infinity. So that's really like the end of regular class. I am going to do the next one and record it. There's like 10 minutes before lunch still. You guys have 2 worksheets to do. But I am going to do this next one and talk just like people were listening. If you're not listening, it's your study hall time. So see, cotangent is going to use from 0 to pi. And knowing these is going to be, oh, so helpful in the next section. So 0 to pi. And that makes the middle of it pi over 2. We've got up here pi over 4, and down here 3 pi over 4. Cotangent starts with undefined and ends with undefined, has 0 in the middle. And then when I look at the first quadrant, it's always positive, so we'll have positive 1. The third or second quadrant will be negative 1. Then we've got a vertical stretch by a factor of 3. Undefined stays undefined. And then I'm going to subtract 1. And then on the other side, I do not have to factor because there's just a number 1 right here. Or inside, it's just a number 1. So I don't even have to multiply anything by my x's, but I do have to subtract pi afterwards. So my first asymptote is going to be at negative pi. And then the second asymptote is at 0. And then I continue that pattern. So I can write my asymptotes at x equals, my first non-negative is 0. So I'm not going to actually write 0. Plus they are pi apart, k pi, where k is an integer. And while I'm down here, that's going to be the domain, just not equal to. And I already know this answer too because it's always the same. Okay, the period is just pi. Vertical shift, we went down 1. And the phase shift, we went left pi. And I got all that information from my table, not really from my graph, because I didn't even graph it yet. See, at negative 3 pi over 4, I get 2. At negative pi over 2 is negative 1, and then negative 4. Got to make sure we have our correct concavity. That's going to be concave down, and this will be concave up. And we just finish the pattern, and that's it.